Hi everyone, I'm Choi from KAIST, and I'm presenting our paper CreativeConnect, Supporting Reference Recombination for Graphic Design Ideation with Generative AI. This work was done with Sumin, Jeongeon, John, and my advisor Juho. In creative processes such as graphic design, people often use previous design solutions as a reference. As you can see in the image, designers usually collect many reference images in their physical or digital spaces. These references play a crucial role in all stages of the creative process and are especially important for igniting novel ideas. One of the effective methods to generate new ideas with references is recombining them. People get multiple references and mix them to make something new. So two steps are involved here, which is finding the parts that are worth mixing and mixing those elements in a novel way. However, this process often takes a lot of time and effort. To find the elements, designers should look into each reference image to find something valuable. Also, there can be many different ways of mixing them, so they have to explore and choose the best one, which often requires them to draw multiple sketches. Here, we found an opportunity to use generative AI models to solve this problem, as they can quickly understand the image and diversify their generations. Therefore, this work looked into how to support graphic design's reference recombination process for ideation using generative AI. Before designing how to support this process, we conducted a formative study to understand how designers do the reference recombination and the challenges of this process. The study was conducted with 6 participants, and we gave them a design task and observed their workflow. We first gave them separate time to search for the references and asked questions to know how they extract the elements from them. Then, while sketching their idea, we asked about how they mix the elements into their idea. Lastly, we asked about their challenges during the post-interview process. The first finding was that there were 2 different stages of ideation using references. First is conceptual ideation, where people focus on elements related to the design topic and usually generate multiple drafts by combining the references. However, in the next step, called visual development, they focus not on exploring different recombinations, but more on applying some elements from the reference to their own idea. Therefore, this work focuses on supporting the recombination in the initial conceptual ideation phase. Then, we analyzed what kind of elements designers extracted from the reference and defined 4 categories, which are subject matter, action and pose, theme and mood, and arrangement. Through the interview, we identified some challenges during the process. For finding the elements from the references, participants said that it was impossible to discover all valuable elements at one glance and had to check them multiple times. Also, they wanted to brainstorm further related concepts from what they found on the reference image, but it took much work. For the second step of mixing the elements, participants are often frustrated as they cannot sketch out all possible combinations. Lastly, when we asked participants what kind of support they want for this step, they want it to be incomplete so that they can put their own creativity on top of it. The formative study result led to 4 design goals. First, to find the valuable elements to combine. The system needs to facilitate element extraction from the reference images and suggest diverse relevant elements. For mixing them, the system should support users in generating diverse recombination options, but still present outputs in an incomplete format. Based on the design goals, we made a generative AI-based system called CreativeConnect. This is how the system looks like. And now let's see how the system works. Here is Sarah, a graphic designer who is struggling to come up with a new idea. So she went to the reference websites and found many reference images that she liked. Then, as she imports one of the images into CreativeConnect, the system automatically detects keywords from it. She can select her favorite keywords from here and find missing ones that she overlooked. After she repeats this process for all images, she can get a mood board of her reference images with keyword notes. Now she wants some new concepts based on what she found so far, so CreativeConnect recommends new keywords based on the current mood board. If she needs an idea based on a specific set of keywords, the system can also recommend them based on it. As she finds a new idea, she can drag it into the mood board. Now that Sarah has enough keywords, she moves on to the next step, which is to mix them up into a new design idea. As she selects some of the keywords that she wants to mix, the system suggests some diverse recombinations of them, first in the form of text descriptions, and then by generating an image in sketch format. Finally, she refers to these sketches and descriptions and completes her novel design of Santa riding a turtle sled. To evaluate whether CreativeConnect matches our research goal, we conducted a user study with 16 participants. The study was conducted as a within-subject comparative study. The baseline system looks exactly the same as CreativeConnect, but it includes a layout diffusion model on the right panel, and there is no automatic keyword extraction and recommendation, but we provided ChatGPT instead. Participants were given a task to draw an illustration of a different set of design topics with 10 reference images in each session. Each session involves 30 minutes of ideation session with a given tool. We had 3 research questions. First, we evaluated how well CreativeConnect support the 2 reference recombination steps. Then, we evaluated the quality and quantity of design ideas using both tools. Finally, we observed how users use the tool in a different way. For the first step, the survey results showed that CreativeConnect was useful for discovering elements from the references. Then, we counted how many keyword nodes were added by the participants in both conditions, as the keyword node acted as an element of the recombination in both systems. As a result, we found that users left more keyword nodes with CreativeConnect. Also, while baseline users mainly extract the keywords at the initial sketch, CreativeConnect makes them to keep finding keywords again for each sketch, which can be a positive signal for them to explore diverse ideas. Next, for making recombinations, the survey results show that CreativeConnect was useful for generating multiple ideas. We also analyzed how diverse recombination that participants tried out in both conditions. So, we calculated how much the keywords that the participants gave into the model together were similar to each other. As a result, participants created semantically more unique combination of keywords as input when using CreativeConnect. This means that users with CreativeConnect explore diverse recombinations compared to the baseline. The second RQ is about the quantity and quality of the generated sketches. As this table shows, participants with CreativeConnect generated more sketches in a given time. Also, participants perceive their idea as more creative when using CreativeConnect. Lastly, we analyzed how users use CreativeConnect. First, we asked participants about the source of inspiration for their best sketch. The results show that they got more inspiration from the tool when using CreativeConnect, while they got more inspiration from the reference images with baseline. This shows that CreativeConnect can prevent users from being fixated on the reference images. Also, there were differences in how they utilized the generated images for their ideation. Users with CreativeConnect usually reinterpret the generated images in their own way. For example, when CreativeConnect generated an abstract image of circles, participants reinterpreted it anew and developed a design concept of a network connecting planets. On the other hand, the output from baseline system led users to focus on a specific visual element or details. For example, participants look at the generated image as a reference for accurately drawing and positioning a spacecraft here. The survey result also showed how participants utilized the system output in their idea sketch. They perceived CreativeConnect as better for thinking about what kind of output they want, which means that they use the system as a guide to think about what they want rather than just accepting it as their final result. Although we found many positive factors of CreativeConnect, the overall creativity support index of the 2 tools showed no differences. We found a reason for that in our first discussion point. Here, we propose 2 discussion points and design implications for the future creativity supporting tool. Through the post-interview, we found out that CreativeConnect and the baseline system both provided valid creativity support, but in a distinct way. In the baseline system, users have to specify the details to put on the system, which makes the system accurately mirrors the user's mind. Therefore, this is helpful for creativity in terms of implementation, which is about actualizing the design idea. On the other hand, the input of CreativeConnect is a keyword without exact expression, and the system generates its own recombination. This makes the output very abstract and unexpected on the user side, which helps creativity in terms of inspiration and helps them to break the creative boundary. Therefore, we need to design a tool that supports different types of creativity support based on the user's current need and ideation process. We also uncovered the effect of the low fidelity output on creativity. 12 out of 16 participants preferred the sketch output over the complete image, mainly because it makes many empty spaces and encourages them to fill it up with their own creativity. This also prevents fixation on the specific details. Therefore, we can design a future creativity supporting tool that gives low fidelity output when the user wants to explore different concepts without fixation, but provides a complete image when they look for the references for visual details. For more information, please refer to our paper and project website. Thank you.